Hey, Math 110 students, we're finishing up finding the complex zeros of a polynomial function. So we can have a third degree, a fourth degree, fifth degree polynomial function, and we can find all of the zeros, real and complex. All right. So let's think about this for a little bit. We're going to do the problem here. One big problem altogether. All right, finding the complex zeros of a polynomial function. And we're going to do f of x equals 2x to the fourth minus 11x cubed plus 13x squared minus 44x plus 20. We're going to find all of the zeros, complex and real. And I have written it over here on my thing just so we can all do it from beginning to end all together. And you need to, I'd strongly suggest you writing this one down too. All right, so first off, it's a fourth degree equation, right? So we are going to have 4 complex zeros. And when I use this word complex, I'm meaning you can have real zeros that actually cross the x-axis, but you can also have imaginary zeros. So we're going to have 4 of them. And Descartes' rules of sign, if we look right off, positive to negative, that's 1 sign change. Negative to positive, 2 sign changes. Positive to negative, that's 3 sign changes. And negative to positive is 4 sign changes. So you could have 4, 2, or 0 positive real zeros. Okay. All right, now let's do Descartes again, but now let's do it with the negative x. Remember, if you have an even exponent, then the negative x is going to be the same. It'll be 2x to the fourth. But if you have an odd exponent, your sign's going to change. This one will become positive 11x cubed. Negative x squared is the same as x squared, so this stays the same, 13x squared. But negative 44 times negative x will be positive 44x, and then the 20 stays the same. All right, now how many sign changes? Positive to positive, 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 positive. No sign changes. I will have no negative real zeros, which is very helpful. All right, now what are our potential zeros? If I go too fast, you slow me down. If I go too fast, you slow me down and rewind me. All right. How do we find our real zeros? Remember the p's and the q's. The p's and the q's. We're going to take our p's divided by our q's. Our p's are our factors of 20, which since I have no negative real zeros, I don't have to worry about the negatives. So my factors of 20 are going to be positive 1 and positive 20, positive 2 and positive 10. 3 doesn't go into 20, but 4 goes into it 5 times, and there's no numbers in between 4 and 5. So there you go. For q's, these are the factors of 2. It's just 1 and 2. And then the p divided by q is going to be 1 over 1, which is 1. 1 over 2, which is 1/2. 2 over 1, which is 2. 2 over 2, which is 1, which I've already got. 4 over 1, which is 4. 4 over 2, which is 2. 5 over 1, which is 5. 5 over 2, which is 5/2. 10 over 1, which is 10. 10 over 2, which is 5. 20 over 1, which is 20. And 20 over 2, which is 10, which I already have. Okay, now our question is, which of these, do we have 4 positive real zeros? Do we have 2 positive real zeros? Or maybe none and everybody's complex? And on a 4th degree equation, everybody could be complex. All right, let's put this into our calculator, and we can use this wonderful button called the second entry button. And let me show you how it works. All right, so this is the one that we're plugging in here. Okay, so I'm plugging in 2x to the fourth, and I'm going to try all of these. Let's start with 1, okay? So 1 to the fourth, because I'm just plugging in 1 everywhere I have an x, and I'm going to see if I have a remainder. Minus 11 times 1 to the third, okay, plus 13 times 1 squared minus 44 times 1 plus the 20 at the end. And the factor theorem says that if I get 0 as an answer, then 1 as a factor. I don't. I got negative 20 as an answer. So I know 1 isn't 1. Okay, cross them out. All right, let's just do the whole numbers first. All right, so let's go to 2. Now, I don't want to type all this in again. And here's a really nice thing. I've got this yellow word entry above the enter. And if I go second to get to the yellow word, second entry, look, it puts in the exact same thing I just had. Well, I don't want to do it with 1. Now I want to plug in 2. So everywhere I had the 1, I'm going to replace that with the 2. And we're going to try it with the 2 and see if we get 0 as an answer. If we get 0 as an answer, then that means 2 is a factor, or 2 is a 0, excuse me. Nope. Cross out 2. Try it again with 4. Okay. Second entry. And now I'm going to plug in 4. 4 in place of 2. Oops. 4 in place of 2. 4 in place of 2. And 4 in place of 2. Nope. Did not get 0. So I'm going to cross out 4. Let's try 5. Got a good feeling about 5 as we work our way through. Second entry. And now instead of the 4, I'm going to plug in 5. If I get 0, then I know my remainder is 0 and that this is in fact a 0. In fact, that's the whole point. If you get 0 as the answer, it's a 0. I got 0 as an answer. 5 is a 0. Awesome. All right, so that's my first one. Now, I don't want to keep working with this big guy. I want to use the depressed equation. Now, how do we get the depressed equation? We put in, we're going to do the synthetic division, 5. So I'm going to write out all my coefficients, 2, negative 11, 13, negative 44, and 20. If I'm going too fast, what do? You slow me down. You play me on 0.75 speed. Or you just rewind me. Or you put me on 0.75 speed and remind me. How do we do synthetic division? Synthetic division. All right, we're going to pull the 2 down. We multiply. 2 times 5 is 10. Add them up. Negative 1. Negative 1 times 5 is negative 5. Add them up. 8. 8 times 5 is 40. Add them up. Negative 4. Negative 4 times 5 is negative 20. Add them up. 0. And that was the whole point. This one, that would be your remainder, and we don't have a remainder. So because 5 was a 0, x minus 5 is the factor. And what's left is, this is your constant, start at the end, constant, x term, x squared term, x cubed term. 2x cubed minus 1x squared plus 8x minus 4. So now we've got it factored. Let's continue on, but let's do it with the smaller one. Let's do the smaller one. Let's try the 1/2 and the 5/2. All right, let's try 1/2 and 5/2. All right, so my smaller depressed equation, it's kind of a sad equation, it's depressed. No, I'm just kidding. Depressed meaning smaller here. So 2, and in place of x, I'm going to put the fraction 1/2. 1/2, and that is to the 3rd power. And then that's going to be minus 1. And in place of x again, I'm putting 1/2, but we're squaring that one. Plus 8, parentheses, 1/2, minus 4. So let's see, does 1/2 work? Oh, I already found my second one. All right, so 1/2 is my next one. Okay, so 1/2 is my next one. All right, well, let's do depressed equation again. All right, so I'm going to do synthetic division. Now my coefficients were 2, negative 1, 8, and negative 4. You bring down your first one. 2 times 1/2 is 1. Add them up, you get 0. 0 times 1/2 is 0. Add them up, you get 8. And 8 times 1/2 is 4. Add them up, you get 0. And that's what I was supposed to get. This is your constant, your x term and your x squared term, all right? So what do I have so far? We found the x minus 5. We found the 1/2, so the factor was x minus 1/2, and now I'm left with 2x squared plus 0x plus 8. All right, these will be my last ones, and I can solve this just by setting 2x squared plus 8 equal to 0. Or you could use the quadratic formula. I think we're out of real zeros, so the rest of our zeros are going to be imaginary. So let's solve this. 2x squared then would equal -8. X squared would then equal -4. So we divided both sides by 2. Solve for square root by taking the square root of both sides, and squaring undoes square root. So I get x equals, and here's the problem. I'm taking the square root of a negative. This is what makes it imaginary. The square root of the 4 would be plus or minus 2, and the square root of the -1 is the I. Plus or minus 2i, right? So then my zeros were x equal to 5, x equal to 1/2, and x equal to plus or minus 2i. All right, now if the book asks you how to write these answers, then you can just put it right in here like this. -2i, 2i, those are the conjugates, 1/2 and 5. And we found 2 real zeros which fit what Descartes' rule of signs told us to expect. All right, so that finishes up finding complex zeros. And your keyword today is complex. Although it wasn't really complex, was it? Yeah, maybe so. All right, hang in there. You're doing good work. And call me at 268-2516 or use the Ask My Instructor button if you need any extra help.